Okay, good evening. Welcome to
MathyMath number 183.
MathyMath183. So this is a problem. Scratch book. This is a problem from your geometry book. It's problem 7.39. It says point D lies on side YZ of triangle XYZ. Okay, such that angle YXD equals angle ZXD. Given that XZ is 8, YD is 3, and DZ is 4. Find XY. Okay, I think we got the picture drawn right.
So we'll just call XY A.
Alright.
Well, we have angle bisectors and lengths. This seems like a good idea to use the angle bisector theorem here.
Okay. What does the angle bisector theorem say?
Well, I think it says that this to this equals this to this.
Okay, so
But we should probably prove it to make sure.
yeah, let's do that. But let's just do the calculation real quick, since once you do that, it's very simple. So what does the angle bisector theorem say?
I think it says that 3 to 4 is A to 8.
Okay, so what would A be then?
A should be 6.
A should be 6. Okay, so if that's the angle bisector theorem, then A should be 6. Okay, so we got to prove the angle bisector theorem. That's a good idea. Make sure you understand it.
Well, we can use this height here. And we can say that the area of our big triangle, I'll call this H, is 7H over 2.
Okay.
The area of these two smaller triangles, 3H over 2 and 4H over 2.
Alright, good.
Well, this just says that these are in the ratio of 3, or the areas are in the ratio of 3 to 4.
Ah, which areas are in the ratio of 3 to 4?
The area, this to this is 3 to 4.
What is this and what is this?
This triangle YXD
Okay.
and triangle DXD.
Alright, so those triangles have an area whose ratio is the areas are in the ratio of 3 to 4. Why?
Because these H over 2's are all common, you can cancel them out.
Yeah, but why? But what is it about the triangles that allows you to immediately be able to tell the ratio of their areas?
The bases are same height but different bases.
Yeah, they have the same height. Okay, cool. All right.
Well, they have the same height but different bases. So that means that this height and this height should be the same.
Okay. Okay. If what you thought about the angle bisector theorem was true, those heights should be the same. All right. Why might those heights at least possibly be the same?
An angle bisector, it's always the same distance away from the angle that it bisects, like the sides of the angle.
Okay. Why?
Oh, because it's this much away from this side and this much away from this side.
Okay.
It's the same angle degree.
All right. That's kind of a hand-waving argument, but there's a real geometric argument for why this height and that height are the same. So there's a really important geometry argument. Can you see it?
Well, congruent triangles.
Okay.
Maybe use this, and a right angle in these two triangles.
Okay. So what do we know about those two right triangles?
That they're congruent.
They're congruent.
It means that these lengths have to be the same.
There you go. So there's the geometric argument. All right, so we know those two lengths are the same. What does that mean about the two triangles?
That means that they have the same height.
Yeah.
And that means the ratio holds.
What ratio?
The area ratio.
All right, which is now what?
6 to 8.
Or 8 to 8.
Yeah, 8 to 8. Which
8 to
is
8.
6 to 8 from here.
Yeah. There you go. So the way you prove the angle bisector theorem is you look at the area of these two triangles, YXD and ZXD, and you find that area two different ways. And that gives you the angle bisector theorem. So good job, man. Very nice work.